Hi, my name is Alif Ikmal bin Salihin. My matrix number is 190909. I'm from Bachelor in Aerospace Engineering. My final year project is Morphing Winglet to increase aircraft performance by using shape memory alloy actuator. The introduction is that the long and narrow wing size is desirable because it can offer high lift to drag ratio, which can improve the fuel efficiency, but it restricted to the maximum length of the airport regulations. And current fixed winglet can only be optimized to meet the requirement of the specific flight condition. And if we have a variable geometry of winglet, it can reduce wing load, associate high gas load condition, and weight saving as the weight structure is reduced. The SMA actuator system may weigh up to 80% less than traditional systems such as hydraulic and pneumatic system. And shape memory alloy SMA undergo mechanical shape change at the low temperature when heated, then come back to initial shape. That is why the SMA material can be used as an actuator. The problem with the current technology is that fixed winglet can only be optimized on a certain flight condition only, which is for the cruising speed only, but non-cruising are not very efficient. Winglet can increase wing bending load on the main wing of an aircraft, and long wingspan are more desirable because of aerodynamic efficiency, but it restricted with the airport regulation, which is ICAO Code E. There are many conventional actuator systems that can be used, but it's more heavy and require high maintenance, and also it requires large space. The objective of this project is to develop the morphing winglet mechanism and to integrate the SMA actuator part and control system to test the integrated morphing winglet mechanism system. And the scope of this project is to measure the force produced by SMA actuation system, integrate the subsystem as a feedback control on the SMA actuator by using LabVIEW software and hardware, prove our concept by testing the step response performance of angle of the morphing winglet. It's more focused on the UAV type of aircraft because the actuator produces a small force and use SMA material which is a nitinol. The chapter 3 is a design requirement. By referring NASA, the best result for winglet is a 15-degree cant angle, so which is the minimum cant angle that need to pass is 15 degree. And every aircraft design must follow FAA regulation such as FAR 23.561 is for emergency landing condition, and then for FAR 23.303 for safety factor and fitting factor is 23.625. And these regulations are to make sure the safety of the pilot and also the passenger. Even though the design is based on the FAA regulation, but the design of the system is focusing on the UAV aircraft only. The SMA actuator is used only nitinol. This is the shape memory alloy experiment to investigate the spring behavior with increase in voltage. So the result we can see here is that the time contract of the SMA spring and the time expand of the experiment spring. The desirable for the actuator is that when they intercept with each other, because of the time is same between the contract and expand, and also the stroke is increased when the voltage is increased. And this is the first actuation design, and the right side is the final actuator design. On the system controller, on the left side is the basic block diagram. On the right side is the actual block diagram with the temperature feedback SMA actuator. This is the control input display where the input temperature is we input the desired temperature, and for the actual temperature is the temperature produced by the system. This is the system integration where the connection from power supply to the actuator, and the actuator to the NIDAC, the NIDAC to the software. And on the bottom side is the complete assembly of the actuator system with the winglet. And this is the experiment where it has been fast forward. It shows the movement of the cant angle when given a temperature input. And then the structural analysis justification is to analysis the shear out failure and bolt pull out failure for every assembly and attachment, and to make sure the margin of safety is more than 0, and all follow the margin of safety, all the results are more than 0. The result and discussion by this experiment is that by increasing the temperature, the cut angle of the winglet also increase. And also it has a 2 region, which is the first region 30 to 50 degrees Celsius, shows that the cut angle increase in faster rate compared to the second region, which is from 50 to 80. The cut angle changing rate is lower due to because already achieve a maximum stroke. And the conclusion is that the morphing winglet mechanism successfully developed, and the SMA actuator and control system is successfully integrated, and the actuator system can change the cut angle of the winglet without any problem. And for the future work, we can include that wind tunnel testing to study the effect of different angle of the winglet and their performance, and also we can test the actuator durability to ensure the reliability of the actuator in the real situations. And the advantage to the community is that the output of the project in future for commercial aircraft, it can be fuel saving, can reduce the cost of the flight ticket, and also passengers are more comfortable in flight because of the winglet performance. And in UAV flight time might be longer and reduce the workload to the UAV operator and maintenance, and also can reduce cost of the UAV. And that's it from me. Thank you very much.